Okay, today's just going to be a short day. We're going to be implementing a function to go with the function we wrote yesterday, which, if we look when we call it, yesterday we wrote this tester populate, which populates a whole stack. But we need to this tester populate only makes laystones, and it only stacks them, and it only alternates their colors. But we need to make one that we can just place a capstone or a standing stone. So we're just going to give ourselves a new function called like a obstacle populate or something. So if we take a look at the code we need a row, a column, we need a type, and we need a color. So let's go one by one. Grid it row column dot occupied would now get true. We would take our members stone type from our parameter here. So we'd say grid column in our members table. Now this is only, we're hard coding it in at the only member because of the way like a standing stone would overwrite all the beneath stones. It really is just based on stack control. So we're just going to put one stone in here. If we need another function, we can make another one, but I think this is fine for now, at least. So stone type will now get a string of whatever the stone type parameter is. So we would just say stone type. We just have to make sure we pass in a string here of a capstone or a standing stone. Now, we also need stone color. We're going to update our occupants amount, which is in our occupants class. So occupants gets 1. We need stack control and stone control, which is based on this stuff. So what we can do is say, right after we give it a stone type, we need to give this one a stone color. Right after we give it stone type, we're going to assign our stone control. So stone control gets the same as our stone type, and then our stack control gets the same as our color. Okay. So I think we're good. So now it's row, column, type, color. So if we take out this old line of a tester, our 3.3 is our middle spot. So our middle spot should be empty right now. Nope, that's not what I wanted. Here, middle spot should be empty, which it is. Now let's try our function. So we're gonna say obstacle populate gets a 3, 3, and then we need a stone type, which is a capstone, and we need a stone color, which why not we do black. So now we condensed these many lines into just one function call here. Hopefully we have a black capstone in our center space. So now we can spawn any standing stone or capstone in any spot with just this one line instead of having to do all of this nonsense or manually placing it every time we test. One thing I'm gonna do is just make our functions consistent with camel case. So reset board is good. Here, clear control needs to be camel case, so let's go to find clear control. Just make sure we're camel case appropriately. Just want consistency. Okay, clear swap is good. Drop stone needs to be camel case. Stone. And then we can kind of plan out our next game plan based on our findings with our debugging here. Next move off grid. I don't know if our function should be all capitals. Maybe that's the convention, I'm not sure. I just want things to be consistent. And we add some camels, some, so I'm just trying to stay consistent. Okay, 4 more to go. Left edge illegal. I think we can actually control find these ones. It's not that much work though. So. So let's see what we know. We need to limit how many stones we lock in this scenario. So right now we only limit our stones based on if we're otherwise surrounded. But here we're essentially surrounded since we can't take all of our stones into the next occupants. So I think what we need to do is count instead of our highest occupant count. See, this isn't exactly right. I think if it's not a caps, I think we need to search our surrounding spaces in our movement event 2 before we lock in how many stones we can pick up. We need to search our surrounding spaces. Anything that's not a capstone or a lay stone, meaning this one, or this one, we need to count how many occupants are in it and save that value as a sort of because right now we can lock this in with 5 stones and we can't move it anywhere, which will get us stuck. So we need to count what our lowest occupant surrounding is. So like in this case would be 13. And if our lowest occupant surrounding is 13, then we know we only have room for 1 stone to pick up. So we need to do something like that. Yeah. Because right now we can lock in, once I hit enter, it will be movement event 3, which means we have to select our first movement grid, yet none of them are legal moves because of our occupant count. So we need to do something there. So I want to write a function called lowest surrounding occupants. Now we need to only count non-capstone, standing stone, stack controls. But the tricky part is we have to count different grids depending on the edge cases. So we got to redo the edge cases and everything, which is gonna suck, but we gotta figure this out. So let's say corner case, edge case, middle case. Now we need to get our movement origin row. I think I'm just gonna say origin row here. Origin row and origin column. Because we need to check what's surrounding us. So if we give ourselves the origin row, origin column, we can access our occupant of our movement origin. Is that all we need? Let's just build it out. So we know it's a corner case if our origin row is equal to 1 and our origin column is equal to 1. That's the top left. If our row is 1, but our column is 5. That is at top right. If our origin row is a 5 and our origin column is a 1, that's a bottom left. And if our origin row is a 5, and our origin column is a 5, that's bottom right. And we need to do this because we need to know which grids to count, and if we accidentally count off the grid, it'll be nil and then it'll crash. So we have to do these edge cases. And we can end it here. So we know we basically need a count, a lowest surrounding occupants count that we would increment by the occupants of our surrounding grid if our stone control does not equal a capstone or a standing stone. So let's give ourselves this lowest surrounding occupants variable to go with the function. I'm going to do it as 0 instead of nil because you can't increment a nil. Surrounding occupants is 0. And we're already preventing us from picking up a stone if either we're surrounded by all capstones or all occupants of 14. So we shouldn't run into a problem there. So on our reset, we reset it, and on our board reset, we reset it. So where is that function? Here. So I guess we could say if our grid at this location, if our surrounding grid location here is equal to is a stone control that is equal to a lay stone, then we would count the occupants, because it doesn't matter how many occupants we have if it's a capstone or standing stone, because you just can't move there. But if we have stone control of a lay stone, then we know we need to increment that lowest surrounding occupant count. But it's not, this is just the case if our origin row is the top left, so we need to check two squares, and those two squares are 1, 2. And our 2, 1. And if either of those are a stone control of lay stone, then we would need to increment our lowest surrounding occupants variable. And no, this isn't exactly it. We don't need to increment it, we need to assign it. We need to assign it based on the amount of occupants that are in that grid. So we're gonna say, we don't need to increment it. We need to assign it based on the occupants. So we would say, if we are stone control there, then we take how many occupants are in that grid, assign it to that variable. But it's not exactly all we need to do, because we want this to be the lowest amount of surrounding occupants. So this is tricky because we want, maybe we do start this off as nil because we don't need to increment it, we're just assigning it. So let's start off as nil because we don't want 0. Since the function is trying to be a lowest number, we don't want it to initialize at a lowest number because that could be buggy. So lowest surrounding occupants gets nil. So how do we say this? We only want to assign this if this occupants is actually less than our current lowest. See, and this is where it would crash because this would just be nil, but it's a nil value, not a nil. It knows it's nil. It's not assigned. So we might be okay here. Yeah. Okay. So we only want to assign our lowest surrounding occupants if the occupants in that grid is in fact lower than our current lowest surrounding occupants. But this would be nil. I don't know how to fix this because we need to. Oh God, I don't know how to fix it. I think, no, I don't know how to fix it. I think if it's nil, we need to just assign it. Otherwise, we need to do it based on the. So we can say if our lowest surrounding occupants is nil at this point, then we go ahead and just assign it in the first place. So we would say that we get this. Then we would say, otherwise if it's not nil, then we only assign lowest surrounding occupants if the amount of occupants in this current grid is less than our current lowest surrounding occupants. So this should have the result of only putting in the lowest amount of, it should have the result of only putting in the lowest amount of occupants. But we have to assign it if it's nil, which in that case, it just gets assigned to that grid's occupants. So we need something similar here for our other one. We can say this is our 2-1, and if our 2-1 occupants is lower than our lowest surrounding occupants, our current lowest surrounding occupants, then this would be our new lowest surrounding occupants. So that covers top left. So like all that code just to account for if our stones are in the very top left and we're surrounded by a big amount of occupants. Now this actually won't do anything, this just assigns our lowest surrounding occupants, so we still have to call this function and then do something with the lowest surrounding occupants in order for this to do anything, but so now if we're the top right, we need to check the grid directly to the left of us and below us. So left of us would be row 1, 4. And beneath us would be grid 2, 5. 2 rows down, the column all the way to the right. And we're checking the stone control here. Well, yeah. If the stone control is laystone, that's the only time we would assign these things. And we're saying if we haven't assigned any value in our lowest surrounding occupants yet, then our lowest surrounding occupants would just get assigned to be this grid's occupants. We say else if this grid's occupants are in fact lower than our current lowest milestone occupants, that's when we need to update our lowest surrounding occupants to be equal to this grid. Yeah, and if there's no stone control, nothing would happen to that lowest surrounding occupants because there are no occupants in the surrounding space. So we would do the same thing here. If we haven't assigned this yet, then we would assign it here. Else if we would also assign it if the occupants in that space is less than our current surrounding occupants. Okay, I think that's it for top right. Let's go on to bottom left. Our bottom left, we need to check 2 spaces right above us and right to the right of us. So right above us would be 4, 1. And to the right of us would be 2, same row, so 5, 2. So going to check our stone control first. And if it's equal to a lay stone, then we worry about assigning this stuff. And we're going to check if we're nil yet, and if we are still nil, and if we're still nil, then we need to give ourselves an actual value in our lowest surrounding occupants. That value is going to be the occupants of this very grid. We also need to assign that if our current grid's occupants is less than the current lowest stone occupants. If that's the case, we need to assign that to be equal to our grid's occupants. If stone control is a lay stone, this is the one to the right of us in the bottom left. We're going to say if the lowest surrounding occupants is nil, then we're going to go ahead and assign it to be our current grid occupants. So if our grid's occupants is less than our lowest surrounding occupants, we need to update our lowest surrounding occupants to be equal to this grid now. This grid's occupants. Okay, I think that's bottom left. And then we've got our bottom right. Now if we're in the bottom right, we need to check one right above us and one to the left of us. So the two grids we need to check are right above us, which would be row 4, column 5, and to the left of us, which would be row 5, column 4, or yeah, column 4. 5th row, 4th column, yeah. So we're first going to check our stone control. And if it's a lay stone, we're going to update these values, and we're going to say if this is nil, we're going to go ahead and assign it to that grid's occupants. If that occupants is lower than our current lowest milestone occupants, then we would update it to reflect such by assigning grid's occupants the new lower value. And then we check our stone control. If it's a lay stone, then we check if we've assigned it. And if we haven't assigned it, we go ahead and give it a value for the first time, which would be the occupants of this grid. is if this grid dot occupants is less than our current lowest stone occupants, then we'd go ahead and update that to this amount of occupants. Okay. Now, we still have to do edge cases and middle cases. Then we have to implement this function, but I have to get going. Me and Ryan are driving to El Paso for a concert tonight. And I'm meeting him at 10, and I still have to pack and get ready and stuff. So next episode, we're going to continue to flesh out this lowest surrounding occupants so we can limit the amount of stones we pick up if we're surrounded by not capstones and laystones, but a high amount of occupants surrounding us. So what this is going to ultimately end up doing is, if we're surrounded by, let's say, a 13 stack and a 13 stack and a capstone at the bottom and a 10 stack on the left, it would allow us to pick up 5 stones. Actually, let's say there's actually an 11 stack. So if this is the 13 stack, a 13 stack, and 11 stack, why don't we go ahead and just model this real quick. So we're going to have a 13 stack, a 13 stack, and an 11 stack with a capstone on the bottom. So that's so nice, I can do that now. So like a 13 stack, 13 stack, and then an 11 stack. So what this is hopefully going to allow us to do once we finish it is, right now we're able to pick up 5 stones, which would make all these moves illegal. But we're going to be counting what our lowest amount of occupants is outside of a capstone laystone. So it's going to say, oh, the highest or the lowest amount of occupants is an 11, which means the most amount of stones we're allowed to pick up would be 3, because you can't move any more than 3 into any surrounding spot. So I'm hoping that'll allow us to force us to lock in 3, at which point we lock in 3, we can't move here, but we can still move here. So it'll prevent us from getting stuck there, depending on the amount of stones. And if we were to pick up or only pick up 1 stone, then all of these would be a legal move, you know. So we could move these in any spot. So it prevents us from getting stuck like we currently are. So we still have to do edge cases and middle cases, and then actually implement the function in our movement event 2. But then it should fix that bug for us. If all of this code is right and our lowest surrounding occupants is functioning as intended. But all we did today was start to add this function. So I'm gonna commit with a message saying started to develop lowest surrounding occupants function. Okay, and then we'll git push. We actually also implemented, we actually did one more thing than that today, which was we did an obstacle populate function. So we did two things, but that's okay. We just forgot. We can amend that commit, but I forget how. Yeah, so tomorrow we'll finish that function and then hopefully start testing it out.